Welcome to this video. In this video I show you how to solve problem 4c, how to find the shortest path tree. So you have three options. One, you could use Dijkstra. In this case it wouldn't work because it got negative edges. The other one would be to use Bellman-Ford. This one also is just too much work. So it's exactly V minus 1 times E relaxations, okay? And that's 96 in this graph. That's a lot of work, so I don't want to do this. Instead, I'm going to rely on intuition. However, for you, especially for our midterm or our final, we have access to the internet. We could just look up Bellman-Ford algorithm, and you would just run it through the input graph and you're all good. But for the purpose of this video, I guess what I'm going to do is simply list the shortest path. So I start through V. This is my source. That would be just itself. Oops, what am I doing? So for V, cost 0, we're done. What about A? Well, A has to be through V only. That's only one path. So that's that. Oops, that's 3. Okay, next we have B. The best path through B is either through A or through D. Through A, this would be VAB. And that would be 3 plus 5, 8. There's another one, could be through D. But to get to D, I need to compute shortest path through D. And I don't know that yet. So I'll just compute it here. Okay. There is one through V. VDB. Cost is 4, right? 7 minus 4, no, it's 3. Okay. Another one is to get to D. It's either through V or through G. So to get through G, I have to get through F. So V, F, G, D, B. This one is better. Okay. Another way to get to D is through E. Okay. Now to get... Yeah, let's just write that. Though I know it's already, there's no path better than this one over here of 2. Because, notice, to get to E, I have to either get through C, which means I have to get through B, which means there's a cycle. But trees do not have cycles, so we cannot do this. And the other option is to get through H. But notice, to get through H, I have to get through G again. And this is all positive. So why should you take the positive path when there is a negative one? So yeah, there is no other better path, so I'm not going to list any more. So I'm done. Sorry, this is the best path. Okay, now next is C. To get to C, it's got to be through B. But I already know the best path through B. So V, F, G, D, B, C. Cost is 2 plus 1, 3. What about D? Notice I already have the best path through D, which is the one to get to B, right? That's this one, V, F, G, D. Cost, what is that? 2. So you just have to minus, I guess, to backtrack. 2 minus 4, so 2 plus 4, which is 6. Okay, and what about E? To get to E, it's either through C or through H. Through H, that would be what? V, F, G, H, so 1 plus 8 plus 3. The cost is 17, right? So 12 plus 5. But there's another one through C, and I already know the best path through C. So this would be V, F, G, A, oops, V, G, D, B, C, E. And the cost would be what? 3 plus 6, 9. And that's it. There's only 2 paths to E, and I already computed the best path here. Next would be F. Notice the best path always contains VF, so that's VF. There's only one path anyway, there is no other path. Alright, what about G? Again, the best path always contains VFG. What about H? This one is easy. So what we do is, there's only one path to H, which is from G, and I already know the best path to G, which is this one. So VFGH. Okay, and we're done. Now, what we have to do is construct the shortest path tree. To do this, what you have to do is, oh, by the way, I forgot to put these, but these are not necessary because I'm not comparing costs anymore. 8, 9, this is 12. Okay, now all you do is simply trace through these paths. So I'm gonna pick the longest one if necessary, but it's not necessary, I guess. So anyway, start with V, and then A, VA. And notice that the shortest path tree is just a subgraph, really. Okay, now these numbers are the edges. These are not the costs of the path. So what else? For B, it's VFGDB, VF, G, and then D, B, then what else? For C, it's just here. And then for E, it is and then finally H. Okay, and this one has a cost 3. So, okie doke. This completes our shortest path tree. I hope this was helpful.